Hello everyone, in this video we're going to talk about how to graph an inequality, a linear inequality, in two variables. So a linear inequality can be written in four ways because we have four different inequality symbols, right? So we could have ax plus b, or ax plus by is less than c, less than or equal to c, greater than c, or greater than or equal to c, okay? And how we graph those is going to depend on what inequality symbol we're working with, okay? So a solution of a linear inequality in two variables is an ordered pair that makes the inequality true, right? Nothing's different there. We've talked about the word solution before. Same thing, right? X and y that makes the solution true, makes the inequality true. Well, the difference between an inequality and just an equation is we might have a lot of different solutions than those that are just on the line, okay? So it says the graph of a linear inequality in two variables shows all the solutions of the inequality in a coordinate plane. And so this is what it would look like. Notice we have some shading here. So the example that we're looking at is y is greater than 3x plus 1. So how we come to this is we are going to graph just as if we were graphing a slope-intercept form equation, right? We're going to begin with b and we're going to move with m. So if you notice our line here, we have a y-intercept of 1, right? Notice that point right there, y-intercept of 1. And our slope is 3, so we go up 1, 2, 3, and right 1, so our slope is 3, okay? Notice this line here is dashed. That is because we have that greater than symbol there. We're going to see some more about how do we know if it's a dashed line or a solid line here in just a minute. And we have some shading, so we're going to talk about how do we know which side of the graph to shade, okay? So this is just a visual example. We'll talk more about the details right now. So it's kind of a three-step process. Step one, we're going to graph the inequality the same way we would as graphing an equation in slope-intercept form. Here is how we determine if it's a dashed line or a solid line. So if we have just a greater than or less than, right, no or equal to, then it's just going to be a dashed line. If we have or equal to, right, greater than or equal to or less than or equal to, then we will graph a solid line because values on that line would also be solutions, okay? Once we graph our line, we're going to pick a test point that is not on the line to determine if the test point is a solution to the inequality, okay? 0, 0 is a great test point to use because you're plugging in 0 for x, 0 for y, and it's really easy to solve the inequality. We can do that as long as our graph, as long as our line doesn't go through the origin. If it does go through the origin, just pick another point that's not on the line, okay? So now we're going to plug the test point into our inequality. If the test point is a solution of the inequality, then we shade the half of the coordinate plane that contains the test point. Okay, so it could be to the right of the line, to the left of the line, above or below, just kind of depends on what your line looks like. If the test point is not a solution of the inequality, you don't have to find another test point that is, you just shade the other side, right? So if the test point you chose is not a solution, you shade the half of the coordinate plane that does not contain the test point. Okay, so let's do a couple examples here. In example 1, we're going to graph y is greater than or equal to 4. Okay, so remember when we have like y equals a number, it's a horizontal line, right? So this is a horizontal line, and it is or equal to, so it will be a solid line. And we're just going to go through 1, 2, 3, 4. So that would be right here. Y is 4, right? Y is greater than or equal to 4. And so now I'm going to plug in my test point, right? The origin I'm going to use as my test point. So I'm going to say for y is greater than or equal to 4, I'm just going to plug 0 in for 4. Okay, now I'm going to evaluate this. Is 0 greater than or equal to 4? Well, we're going to say no, right? So now I'm going to shade the top part of this coordinate plane, or in other words, the section of the coordinate plane that does not contain my test point, okay? All right, let's look at one more. We want to graph x plus y is less than 5. Okay, we want this to be in slope-intercept form, right? So we want to subtract x so that we have y isolated. We want to say y is less than negative x plus 5. So now I'm going to graph negative x plus 5. So we're going to go 1, 2, 3, 4. We're going to put our y-intercept at 5. And our slope is negative 1. So down 1 and right 1, or up 1 and left 1. Okay, so now I'm going to draw my line here. And now what I'm going to do, since this was just a less than sign, I need to change this to be a dashed line. Okay, so now we change it to being a dashed line. We can put arrows on the end. And now we're ready to choose our test point. So I'm going to once again choose the origin as my test point. So now I'm going to plug 0 in for y. I'm going to plug 0 in for x. And I'm going to solve. So I get 0 is less than negative 0, which is just 0, plus 5. So is 0 less than 5? Yes, that is true. So now I'm going to shade the portion of my graph that contains my test point. Okay? Or in other words, all of this section that's kind of like below, or you might say to the left of my dashed line. Okay? And that is how we graph linear inequality.